Welcome back. Hopefully everyone was successful in using argmin in exercise 3. Now we will continue with Lloyd's algorithm. Now, in exercise 4, we are given a clustering and we are asked to compute the center for each cluster. We know that the center is computed by taking the mean of the points in the cluster. Now we implement this in code. To do so, we can use a function from NumPy called mean. We apply this to cluster J and we can find the new center that way. Let's run our code and make sure it runs. In exercise 5, we want to be able to return the within cluster sum of squares when we are given the squared distances. We've given you a hint to use numpy.amin. Using that function, we pass an array of input data and the axis on which to evaluate, and in return, the minimum of the array is given. We have provided an example for which for every column we get the smallest value returned and then added together. Running our code, we see that it passes. Lastly, we have provided a function called hasConverged, which will check to see whether the centers have moved, given 2 instances of center values. This will be helpful in exercise 6. On your own, attempt exercise 6. You will want to combine what we have done in the previous exercises to create Lloyd's algorithm. Let's recall the process for Lloyd's. Given an initial set of centers, find the squared distance for the points to the centers. Then assign the points to a cluster, which we did in exercise 3. Now given the cluster, recalculate the centroid for the cluster, which we did in exercise 4. Finally, use the hasConverged function to see if the centers have moved. Once you have completed exercise 6, we have provided some code so that you can visualize how the points were clustered. It should be noted that we walked you through how to implement k-means, but there are already existing implementations as well. SciPy's implementation is below and will yield similar results.